don't bother me, Sykes.
Right.
I think that was the first thing I said.
Probably.
No,
Second.
probably. Yeah. Yeah. Yeah, it was the second thing I said, and that was based on the first thing that he said. Probably. So I ended up, because of my association with the group at Yorktown, I decided, well, for my PhD thesis, I'll work on extending APL. I mean, I sort of knew they were talking about things like that, and I thought, well, that sounded interesting. And I'll start to talk about that in a moment. So, if you take a look at what were people saying about programming languages back in those days, you've probably seen this saying, if you give someone a fish, you'll feed them for a day. If you teach someone to fish, you'll feed them for a lifetime. And you can say something similar about programming. And they did. If you give someone a program, you will frustrate him for a day. If you teach them how to program, you'll frustrate them for life. And that's kind of what computer programming was like in those days, because you were dealing with the computer, often in assembly language at the detail level of the computer. And in particular, you were not dealing with your problem that you were trying to solve. So next, COBOL. COBOL, I expect you know, was the child of Grace Hopper and
Gene Salmon.
And Gene Salmon. And I don't know a single line of COBOL. I'm pleased to say, I'm proud to say. Yeah, and it's basically because Grace Hopper didn't like APL. So I figured, well, then I'm not going to like COBOL either. So I never learned a line of COBOL. So here's a quote about COBOL. The use of COBOL cripples the mind. Its teaching should therefore be regarded as a criminal offense. With maybe a caveat if the only thing you deal with is 80 character records. Maybe. That's a quote from Dijkstra, a well-known computer scientist.
And
Curmudgeon.
and major fan of APL.
Oh! You can't find somebody who says nicer things about APL than Edgar Dijkstra.
It is a mistake from start to finish, carried through.
Yeah, I have the exact quote coming up.
Like that.
Yeah, I have the exact quote coming up. Here's what he said about BASIC. And so he wasn't singling out APL when he said things. It's practically impossible to teach good programming to students who've had a prior experience, prior exposure to BASIC. As potential programmers, they are mentally mutilated beyond the hope of regeneration. And actually, we found that when trying to teach APL, if people have learned how to iterate by writing loops, it can be hard to unteach them that and think in terms of arrays. That was from Dijkstra. Have you heard the saying that if you can't say something nice, don't say anything at all? Dijkstra never heard of that. He never heard that.
It's not a Dutch thing.
I can just barely see my screen because I'm conserving power. PL1. PL1 presents an insurmountable opportunity to fill a much-needed gap. And I've been unable to determine where that came from, except that I heard it from Dick Lathwell. Do you know, Larry?
We were up at Poughkeepsie or somewhere for a retreat for IBM programmers, and the head of the OS PL1 effort from Poughkeepsie, I wish I remembered his name.
Rayton?
No, I think it was a single syllable. It may come to me. At any rate, he started off the first morning in this big conference saying, PLN presents us with an insurmountable opportunity whose solution will fill a bag.
Oh, so that's actually probably a more accurate quote. I tried searching for this quote, and I have a feeling that nobody committed it to paper or typed it it into a computer.
The first half with slight rewording was actually used by Walt Kelly in a poem construct.
Really?
I don't know when.
Ooh, now that would be an interesting one to have. I had thought maybe Dick Lathwell would come to the Toronto meeting, but he was busy on his farm, so he didn't come. So I couldn't ask him about that.
Because Pogo said, Lee is confronted by insurmountable opportunities.
It's a great quote. So what did they say about APL? Now this is the quote that you were referring to from Dijkstra. A mistake carried through to perfection. It's the language of the future for the programming techniques of the past. It creates a new generation of coding bums. And he really wanted to say something negative, but somehow saying it was carried through to perfection wasn't all that negative.
And what's wrong with being a coding bum?
Frankly.
I mean, here we are.
Yeah.
Yeah. We're the home of it. Sounds good.
Yeah. So you answered the question. Okay.
Unfortunately, it's the old folks.
Yeah, that's right.
Yeah. For a while, I was on the team that went around and did accreditation of undergraduate computer science schools. And whenever I went to a school, one of the things I did is check their programming languages textbook and looked up, see what did they say about APL. And this came from, they had the same book at several of the universities. I've been unable to find it again to give the correct citation, but APL is perhaps the most powerful array program language ever invented. It will not be discussed here further because it has so little influence on other offerings. Oh, what a disappointment to see that and to know that it wasn't true. I mean, even Mathematica used to have a citation crediting APL as its genesis, and the OLAP project, Online Analytical Processing, had a citation to APL. APL's had a big influence. In fact, back in the days at Yorktown, when I was working for Larry, unbeknownst to me, I won't give that story again. I say that every time I see Larry. But someone had convinced PL1 to put reduction in their language. Kind of impressive. And then they ran into schedule problems, and so they just did max and min. Yeah. So close.
Well, I wouldn't say so close.
Here's another one that I'm pretty sure came from Joel Moses. APL is like a perfect circle. Adding anything to it will mar its perfection. Algol is like a ball of string. Adding anything to it will only produce a bigger ball of string. But I take that as quite a positive statement. And here I was back in, must have been 69, in Yorktown when I worked there. I think it was 68 or 69. Somewhere in that time frame, and I decided I'm going to work on extending APL. And I, well, gee, what if it's so perfect?
I've heard the second phrase attributed to Lisp with as a ball of mud, actually.
Really?
Yeah.
Lisp is a ball of mud. I've always thought Lisp was rather elegant. Like, I kind of liked Lisp.
Well, I can explain, but, well,
Yeah.
Google does it better.
And more modern languages, I kind of like Smalltalk. I one time started a project to add multi-dimensional arrays to Smalltalk, which went nowhere. So, now to talk about what I did with APL. APL was perceived by a lot of people as being simple and elegant, and I think they were right. That's certainly what I liked about it. And so how do you extend it without disturbing this perfect circle? Well, there are some extensions that will add nicely, and those are easy decisions to make. I'll mention a few. But some things will change fundamentals. And can you change fundamentals without damaging the beauty of the original? And this is a completely unbiased opinion. Yes, I think you can. And not only yes, but yes with a yellow background, which makes it much more striking,
And
I
shriek.
think. And a shriek, yes.
May I
You may.
make an observation here?
Yeah.
There is another question, similar question to one of those on the previous foil. Once you have users and you are providing a system, can you make any extensions or changes
Yes,
that torpedo anyone's program?
yes, Roy?
So I just have a question on the slide. Is that, are you suggesting that you take the perfect circle and make it into a square?
I may want to add a little, I may have to add a little more detail to it. But a square is perfect in some sense.
Yes, of course.
And squaring a circle, that was a big deal at one point.
Yeah.
But-
I want to say, I wasn't joking about
Oh,
that.
no.
That was one of the major
Oh, yeah.
constraints. As soon as we had a real system, then Blackwell and Reed and all prevented things from happening much more readily.
Yeah. Well, one of the first things you had me do was extensions, what is mentioned later, extensions to base value and representation, which are now called encode and decode, which only worked on scalars and vectors, and you wanted me to extend them to higher rank arrays. And one of the problems was that for representation, that would give a different answer because you'd get a one-column matrix instead of a vector. And so we put some measuring into the system, some metrics, to measure how often did people do the representation of a one-element vector. And we were blown away, millions upon millions of them. And we traced it down to a fellow named Seth Breitbart, who was a summer student, who was, by the way, at the Toronto meeting. And by the way, the summer was the only time he wasn't a student, so I'm not sure where that phrase came from. But he had overheard us talking and went and put a couple of terminals into a loop, taking the representation of one-element vectors. When I saw that, I did the obvious. I took 4 terminals, put them into a loop, doing representations of scalars, and I got the okay to do the project. So,
But
now there's a piece of history I didn't plan on
But
talking
the
about.
coordinates were wrong. But the coordinates were wrong. Due to Larry Reed arguing that it should conform to the inner product.
Well, but it conformed to the inner product with what I think is the arguments backward.
Did we ever tell you
Jay
that?
actually reversed them.
Did we ever tell you that we did that?
That it actually got implemented?
We're talking
No.
about outer product.
But
No,
did it
representation
stay
is
in the
out.
product?
Yeah, but
Did it stay in the APL product?
the base value is inner product, and if you.
We're talking about representation of a one-element vector?
I want, which is the behavior J now delivers.
No, we changed it. The result of that was going to be different after we made the extension.
Oh, I appreciate that. That's about 69 that happened.
Yeah, I remember.
Well,
We went from singletons to arrays. But there's also the
APL
argument about
360.
whether the.
Oh, yeah, the APL 360 was there. I did this back in, it might have been before the Type 2 product came out.
there was another problem with base value representation that may never have been fixed. Someone called and complained, and I tried to, by golly, the thing didn't work right.
Quantity T.
If your argument in representation is non-integral,
Yeah, quantity T.
some fractional values in there, then the base of rep doesn't come out right. And it didn't happen with all fractional arguments, just a few, and I don't remember, and I lost track of the piece of paper that had it on it decades ago.
I wouldn't be remotely surprised.
Well, I mean, what subsequently happened is representation stayed quantity T insensitive, but modulus, the resident, became quantity T sensitive. So that was the change. The quantity T, the modulus was never quantity T sensitive, and then it became quantity T sensitive. I don't know, late 70s.
So that's yet another incompatibility?
between representation and quad CT and
Yeah, we
which
try to define one in
yes.
terms of the other, and you get different answers.
That's right.
Yeah.
Unless you set quad CT to 0.
Yeah, yeah, but
Let me
the
move on.
average user
Yeah,
doesn't,
yeah,
he
we-
thinks of you as not working.
Well,
So
here's an
that's-
example of an extension to a circle that might be okay. A sphere is perfect in kind of the same sense as a circle, except we've added dimensionality. And it just happens that if you shine a light on a sphere, its projection is a circle. Assuming you've set it up correctly. You know what I mean. I set it up correctly, so. So does that answer the question? The problem is, if you take a cylinder and project it at the proper angle, that also has a projection which is a circle. The only difference is this one has sharp edges, if you get my pun. And so, you know,
That's a short joke, guys.
yeah, I mean,
I got it.
so extending a programming language like this is not like mathematics where you can prove things. There's design. It's an art and a science. No one formalism is correct. I mean, I was able to prove to my satisfaction that my extensions to the arrays of APL at least were correct. I was not able to prove that the sharp extensions were incorrect, and I don't believe that they're incorrect. They're different. They're just different. And so you have to make decisions. And that was my job, to make decisions. And whenever you make a decision, there's somebody who's going to wish you made a different decision. I'm glad nobody is going to argue with me on that statement, because then we'd have a difference of opinion.
Too many of us.
So one thing you can do to extend is extend the domain of data. The original APL only had numbers and characters, and the numbers came from the real number field. There were 256 characters. I'm not sure why that's relevant, other than you want to say in front of these newcomer students that we're better at storage than those other languages, maybe. So adding complex numbers, not terribly.
I've never seen anyone stand up and assert that there are only 256 characters in the Really? I mean, in one implementation that we're familiar with, certainly so.
Well, I am talking about,
What
I
is-
guess, in this case, the implementation. That's a very good point.
wait,
I'm not talking about the language here, am I?
Quad AV on a new implementation might comprise all of Unicode.
And indeed, modern APLs have
I
a different
Even,
variable, but
How long was the deck light?
Excuse me?
How long was the deck light?
Well,
Or the burrows light? Because that would have defined how long quad AV was. They might have been 512.
so Larry makes a good point. There's a
Yeah.
distinction between extending the language and extending the implementation. Complex arithmetic, as far as the characters in Unicode, as far as that goes, is an extension to the implementation. Complex arithmetic is an extension to the language in that now the number field is the complex number field, not the real number field. The real change comes when you start extending the functions, which is, of course, the next trivial thing you can do. See, now I wish I had given this talk here before I gave it someplace else, because these are good points. So extending the operations, extending functions so they work on complex numbers. There'd be no point in having them unless you could add them together and do other operations. That did involve changing some functions. For example, the cube root of -2. Suddenly, we started giving a complex number in the first quadrant, where before we gave quite proudly. I should have said -8 so I could compute it.
Yeah, right.
But you know what I mean. So there were actually some changes because of that. But for the most part, it was kind of trivial, obvious, non-controversial. So extending, and I already mentioned that extend, concatenate, encode, and decode to multi-dimensional arrays, that was the first job. We actually had some discussions on the extension of catenate, on what it would mean to catenate along more than one axis at a time. Gene McDonald and I had long talks and talked about ending up, catenating along them diagonal and having, the other part 0, and, at some point you have to stop. Even with encode and decode, we had discussions about, whether we should do a dyadic transpose at the end to move out data. I mean, we pretty quickly decided we shouldn't do that, but, you got to consider these things. Adding new methods is typically not terribly controversial, so formatting, trigonometry, matrix inverse, if you've got complex numbers, eigenvalues are an obvious thing to do. More deciding what we should do as opposed to an argument about not doing anything. Adding new data structures, though. Now we get a little bit of a mess. We talked about ragged arrays, which we never did. Arrays of arrays, what I now call nested arrays, with tip of the hat to Bob Smith, who gave me that notation, was really not very controversial. I certainly left the group with the idea that we ought to do that, because I was working at university. I wasn't allowed to read their papers and things like that. But it ended up to not be controversial, but it was done two very different ways that never did come together again. And then mixed arrays, non-homogeneous arrays. That was controversial almost from the start. I remember talking to Ken when I was first working on the ideas about arrays, and I said, well, if you allow this, then you might end up with a number and a character in the same array. And he said, well, what's wrong with that? So I went away and didn't worry about it again. I think Ken subsequently changed his mind on that topic.
Twice. Sure, big deal, had a mixed J as a
Interesting.
single piece
I have no knowledge, but I think, and possibly even agree with the people, mixed arrays cause a lot of problems for the implementer.
Yeah, but we're not talking about that.
But we're not talking, and in particular, simple arrays, you can generally write faster algorithms on them than you can on nested arrays. And I think that should never be a reason for making a language decision. If it were, our scan function might have associated the other way, because you can do a minus scan much faster if you associate in the other direction. The reason Ken chose to not do that is got more interesting answers with the one he did. I think I said that exactly backwards.
Yes.
So take what I said,
Yes.
turn it over, and you know what I meant to say. Yeah, I said it exactly backwards. So what's important is, are you computing interesting results? And I would like to never, this question of tweaking a definition so that you can make implementation faster will come up again. But this was very controversial and remains so. Next thing, we could make changes in the syntax. And oh, did I get beat up about this? Can we simplify the rules? Don't touch the syntax.
What change were you proposing?
Well, one of the main was vector notation,
Which you did.
which I did. With, I got to say, as a manager, Aidan took good care of me over the years. But we had serious differences of opinion on some of these things, and we had a lot of heated arguments, but boy, he always took care of me. I gotta say he was a good manager.
He didn't.
That way.
It strikes me, it sounds like that he didn't foist his views. This is what you think you should do, he supported you in that, even though he disagreed
Reluctantly,
technically.
but, yeah. And the same is true of Ken, but Ken also then went off and did what he thought was right, and as he should.
Yeah.
as he should. This was a difficult time.
Yes.
But this was enough that in a public meeting, and I forget exactly where, I think it might have been Gaithersburg, or maybe, when was the Washington APL meeting? I don't know, one of them, I gave a presentation.
Aiden attacked you at the Washington APL meeting.
Say again?
Aiden attacked you.
Yeah,
at the
in public, he said something like, touching the syntax is, I can't come up with the
He
word.
was implying it was a criminal act that it had
Yeah.
no place in language.
Right. In a public meeting, my manager's telling me that. And yet I didn't change it. So, so far we're still on what I was telling these students, although not in this detail, but we're going to be out of that pretty soon. So first, nested arrays. I'm not going to spend any time on this. We know what an array is. Here's some examples of arrays. There's one with all numbers. There's a three-dimensional array with all characters. We know what that looks like. The arrays of APL2 are rectangular in the extended sense that we all know. And at each position in an array, you can have a single number, a single character, or another nested array. And that's pretty much it. So here's an example of a three-element vector that contains a scalar 2, a character vector, and a numeric matrix. I won't go into the details there. Vector notation. I have a printout that I got from my first summer at Yorktown where vectors were printed like this on the paper. And I always thought that's something I ought to give to the Computer History Museum, and I tried to find it before coming up here, but I've got a, fan-fold paper with this on it. Yeah,
Was this in display of a function? Or
I think it was input. I'm not sure. I'm not sure.
Well, you said it was printed.
It was printed.
Do you mean the system printed this on blank paper or printed it as part of a function line, or that it was input?
It was a session, and it is, and I cannot say for sure, it is my recollection that it was output.
The left margin.
But from the look of on your face,
Why would we put in parentheses?
did you have the commas? Did you have the commas?
Yeah, the first system, iota 5 was 1, 2, 3, 4, 5, but not inside parentheses.
Okay, maybe the parens are a misrecollection of mine, or maybe it was in the context of a longer expression or something like that. Like if you were going to have a plus here, then you would need to put this in parentheses, I assume.
It is the way, yeah, in a line of code.
Yeah,
There was no vector notation.
so there was no vector notation, and what I understood is removing the parens and removing the commas, I'll adjust that, was kind of a big deal.
Yeah.
And it was wonderful. It was a wonderful thing to do. But these things are never easy. Especially when you work with people who care about what they're doing. I've had jobs before that in IBM where you have really talented people, but they didn't really care. I don't think they lost any
You said that
sleep
it's-
over what they were doing.
You said that it's more about notation. So you were understanding that you're working with mathematical notation, which has quite a long history. And
Yeah. And changing that, that's a big deal.
It's a big proposal, yes.
Yeah.
It's not only big, inertia in people who just used to do things this way, but it also, lots of books, lots of, mental processes.
I didn't bring my power supply, so I'm worried about running out of power before I run out of words. And the problem with making a change like that, and then I remember when I was first teaching APL, and maybe when I first saw it, that looks like 2 plus 3. And you might say that that's 5. But it isn't. It's this. And it's because in the syntax, forming vectors is more important than applying functions. So, heading toward vector notation in APL2, if A, B, and C are arrays, then that's a 3-element vector of arrays. And there's no parentheses, there's no functions involved, it's just syntax. Yeah?
Well, what if A has the value 1, and, well, A is 1, give you the, and C is 4, and B is 2 plus 3.
2.3?
2 plus.
2 plus 3?
I'm,
The A, B, and C are variables, so they are arrays.
oh, okay, if those are,
This is a real APL expression.
A plus B in parentheses.
one slide back, you were showing it, 1, 2 plus 3, 4,
Meant.
meant.
And that's exactly the way it would be.
So it's an implicit
That's the way
agreement
you
to
type
first
it in
form
the-
vectors, then do the syntax.
First you form vectors, then you apply functions. I mean, this is, I'm saying that if you typed in A, you'll get the value of something. If you type in B, you'll get the value of something. You type in C, you'll get the value of something. You type in that, you'll get a 3-element vector, which has those 3 values.
If I type 1, 2 plus 3, 4. Okay.
We know what you'll get, but that's not what I wrote here.
Let's say I,
Go back.
I don't want to spend too much time.
no, it's a quibble over whether it's the name of an expression or the expression itself or the value of the expression.
I mean, that's what you write.
Yeah, okay, and.
This is what it means.
If B were the same as 2 plus 3.
You say if B left arrow 2 plus 3, then B will be 5. We're typing this into a session.
I think we're running down your battery.
You better over a beer.
Yeah, but then what isn't? So here's an example. I don't know if this clarifies anything or not.
That could be the.
Yeah, I gave up.
There's real values for A, B, and C. Now if I type in that, I get this 3-element vector. And if I add it to itself, you get this. And again, that's not C plus A. It's a 3-element vector plus a 3-element vector, because in APL2, the forming of vectors is more important than applying functions, which I claim is the same rule as before. It adds ambiguity to the language, no question. What if B was a function, you know? All bets are off. So it does add ambiguity. And you have to take that into account. Does adding some extension, especially if you're touching syntax, make the whole thing harder to read? And that'll come up again later.
Just increases ambiguity. The ambiguity was already there in APL 360.
Sure. But it increases the possibilities. Yeah. And you have to take that into consideration. I remember one time when the 360, I don't know when in its life, they started to allow off-boundary operations. You know, if you did a full word operation, the numbers used to have to be on full word boundaries. And they would let you do full word operations on any off boundary, and you lost one of your biggest debugging tools.
I think that was a 370 change.
Was it? I mean, it was a good thing to have an on boundary, but I understand, you know, I guess, why they did it.
It was a real blow to us when they
Yeah.
allowed off-boundary, because that programming exception was our #1 debugging technique.
That's what he
Absolutely.
just said, you lost your best debugging.
Yeah, you lost your best debugging tool. And who knows, maybe we lost a debugging tool in APL by doing this. I don't know. Then we have operations on nested arrays. I used outer product because this is easy to understand, even if you don't use APL. Outer product, you can think of it as all combinations. Apply the operation in all combinations. It's not the only way to think about it, but it is a way. You could also think about it as one number applied to the whole vector, and then the other number applied to the whole vector and arranged. That's not how I thought of it. I thought of it like this. Well, in APL2, we allow any dyadic function. And it means this, all combinations. And I used to say things like, and the result will be a 2x3 array. Turns out that's a lie. If there's a result, it will be a 2x3 array. But if f is a defined function without a result, it will still apply in all combinations, but there will not be a result of the outer product operation. You know what the cat-mate function is. They wouldn't, so I showed an example. So how about outer product cat-mate? Well, apply cat-mate in all combinations. You get a 2x3 array of pairs. But here's another way to represent that same result. This has all the same data, it's just arranged differently. It's in a simple array instead of a nested array. You, in some sense, still could interpret that as a Cartesian product if you knew how to handle it. And many people wanted this definition instead of the one I had, including almost everybody in the APL group at Yorktown wanted this definition. And I gave in the spirit of reaching a consensus. Now, in the old days, they talked about what was called the Quaker consensus, right? Where the group would delay decisions until everybody was of the same mind. And that can work in a small group with, maybe 3 or 4 people. The bigger the group gets, the harder and harder that gets to be. And finally, you can't get everyone to agree on everything. Nonetheless, I tried.
How big was the APL development group, the core of the people who were actually implementing this?
I don't know, 5 or 6?
And even at that point, you couldn't get a consensus.
Well, of course, and the problem was APL was becoming commercially viable and more people were interested in it. But, we could not get agreement on this, but, I wanted to get agreement, and I thought, well, I could justify that as a Cartesian product.
Where the timing of all this, what was it relatively as a cylinder?
1982 was when the experimental IUP product came out, installed user program, and in that, outer product had this flat array definition. It was an attempt to reach a consensus. I never liked it. I compromised on other things that I didn't like, but I thought this one was one of the more horrible ones, and it was a visit again from Bob Smith, who, how can you do this? And that made me come to the point that maybe compromise, you can't compromise on other things. And if you look at the case of 2 outer products, using the flat array definition, you get some big answer, which is a 2x3x3 array, 2, 3, and 3, and then an extra dimension of 2 from that one, and an extra dimension of 2 from that one, and as near as I can tell, that doesn't represent anything. So outer product reduction with outer product comma didn't do anything interesting. And so before the program product came out, I changed it back. This now gave us a 2x3 array, 2, 3, 3, of triples, all combinations, 1 from each array. I think it's understandable, it's useful. And I wish, for reasons I'll say in a moment, that I hadn't done it the other way. So I changed that one back. And Larry's comment about making a change when you've got users out there. Oh, boy. I'll have more to say about that. So I'll talk about a couple other sections. Defined operators. When you define an operator, we use parentheses in the header of the defined function. It says apply f and I. That gets a drive function, which is dyadic, which then will apply to an array R. In this case, f is, we think of it as a function, and I is an array. And that's still the syntax of a defined function in IBM APL2, at least. And so you could write something like an axis operator, which would then apply to the array A. And the parentheses were required because of my rule that forming vectors is more important than applying functions. And without those parens, that could be the two-element vector 3 and A. However, in an attempt to compromise with Ken and what he was doing in IP#, he wanted this to mean what I had this mean. And so I made the compromise. So, and in the program product, we have a hierarchy list, and binding things to operators is higher than binding arrays together. The fact is, it made this work. I think it was a mistake.
Even though there's no primitives that actually exploit that.
That's right. It was a mistake, I think. One of the reasons it was a mistake is it led to the splitting of constants. That looks like a constant, that 4-element vector, but I had to bind the 3 to f-axis. And I further think that parentheses are not so bad. You know, I'll use redundant parentheses sometimes just because it makes it easier to read. The fact that the parentheses are needed in the header of a defined function, I think it would have been okay to require them when you applied it to, if one of the operands was an array.
I think it was Trenchard Moore who proposed using a period syntactically to avoid the need for most parentheses.
Yes.
Do you recall that?
Yeah.
And did you ever
Oh my
think?
God, a period again?
I never-
The decimal point, inner product, oh brother.
I never considered it. I never considered it.
And this problem is only when the right operand is an array. If the right operand is a function.
Left operand too.
Huh?
Left operand also.
Yeah.
It's a decision. It's a decision you have to make. So I wish we had left it with parentheses. Sometimes parentheses are good. It reduces ambiguity. But I didn't change it back. So there's an example of one I did change and one that I didn't. Here's another one that still bothers me today. Enclose, disclose, and first. Disclose, enclose, that's the function that applies to any array and returns the scalar which contains that array as its only item. And disclose is defined to be the left inverse of enclose. So you can apply to disclose to anything which is a scalar, and you get what was inside that scalar as the result. So initially disclose only applied to scalars, rank 0 arrays. Well, when you're completing a function, if you have a function defined on some given domain, in this case scalars, you can choose to give it any definition you'd like on values that are outside that domain. In the installed user program, we chose to return the first item of the array. So disclose applied to that 2-item vector, gave you the first vector as the answer. It was Alex Morrow who argued against that and convinced me that there really were 3 functions, enclose, disclose, and first. And we changed in the program product, this is another change, so that disclose removed a level of nesting that kept all the data. In this case, it turned a vector of vectors into a vector of the rows. And added a new function called first, which returned the first item of an array. It allowed the possibility of doing a rest, like Lisp has. We never did that, right?
Yeah, what would be the rest of like a 3x5 array?
Yeah, well, maybe you've discovered why we didn't do it.
Oh, okay.
If you're only dealing with vectors like
Oh,
Lisp,
no problem.
lists like Lisp does, it makes sense. Didn't really make sense. And there were all kinds of definitions proposed for what REST ought to do, but none of them were ever acted on. And I think that's fine. The problem with all these changes, Larry brought up right at the beginning, we were talking about the early days of APL instead of the early days of APL-2. We put out this experimental, it was clearly labeled an experimental product. It's the first time IBM Santa Teresa put out an experimental product. We made clear that we might make changes. What happened? People wrote applications in it. Applications inside IBM they were going to sell, applications and customers that they were going to deploy in their company. And so we make these sort of fundamental changes. It meant that those applications had to be rewritten. Now, they weren't terrible rewrites in most cases, but in at least one case, an application that people at Yorktown Heights Research wrote, they gave up on APL because of it. And that was very distressful to me. In the case of customers, I actually didn't hear very many complaints, but I know that it caused them some work. The bigger problem was with the developers of APL systems. Yeah?
Did you, Jonathan, consider providing any tools that would let people run their code and this was simply logged? Do you view something, a construct that is going to change its meaning in the
We did a little bit of that. That's a good question. One of the changes we made was the tight binding of brackets. If you put brackets next to an array, it's applying to that array. So A bracket 1 bracket meant the first item of A. Even if it was in an expression CBA, where C and B were also vectors, were also arrays. So brackets bound first, and then we bound arrays. Like I say, there's a linear hierarchy of binding. The principles of APL-2, which is still available from Santa Teresa, discusses all this in detail, which makes that paper better than Sominex if you can't get to sleep. Read that paper, and you are guaranteed to sleep. Thank you very much. So, the other vendors of APL, they wanted to be IBM compatible. You know, we're the big guys. In some sense, what we did was kind of, you know,
Industry standard.
being a bully, maybe. So and over time, for example, APL Plus, now APL 2000, and those, they changed their systems so that it became the same definition as the IBM definition. And I'm sure that was painful for them and for their customers, but they did it. Dialog APL took a different approach and added what they call migration levels. And they have a migration level which matches the IBM implementation quite faithfully. But the default is to not have that migration level. So by default, discloses the first function for them. And that sort of hit me in the face. I did some work for Dialog a year ago because they needed to implement a strange case of selective assignment that a customer said, if you implement this, we'll buy your product. So I helped them do a selective assignment. And they said, oh, because you're here, we'll change it so that the up arrow means first. Wow. So these were serious decisions, and I have to admit to having made mistakes over the years. Nonetheless, I'm not going to talk about, and I'm talking about the ones that I thought I made a mistake on. There's other places where we made a compromise where ultimately I think we did the right thing. I mean, there was a lot of input and a lot of it was good. So don't think from this talk we just made mistakes. There's a lot of things we did that the changes were better and we kept it, and I'm glad we did it. Most of the things I didn't change don't really affect the fundamentals. I think the first in disclose is my biggest regret. I think there was never any hope of compromise, getting any kind of complete agreement between IP Sharp and IBM. It just was not going to happen. We had different principles guiding us. So to answer the question, I think you cannot and you should not compromise on technical issues. In the announcement for the meeting, I mentioned about the Illinois legislature trying to pass the law that 3.2 should be the value of pi, because our students shouldn't have to learn all these digits and things like that. And, it fortunately didn't go. There was a time, though, in IBM, you might remember this, numbers go in the name table. In IBM APL, if you type in a constant, it goes in the name table. And if you use that constant in a bunch of places, it only appears once. It's in the name table. And there was you check, this is a constant, we don't allow you to assign it to it. But for some reason, that check got left out one time. And you actually could assign pi to be 3 if you wanted.
What system was this in?
Sorry?
What system was this in?
Which?
System.
System.
Name table.
It was in APL, APL2.
APL2, okay.
Yeah. Hard, still, the jury's kind of out whether that was a good decision to put constants in the name table. It means we had to clean up the name table often. And it also means that we ran out of name slots. That we had applications where 32,000 names was not enough. And I spent the last year removing that restriction from IBM APL2 mainframe. So now
1 year to make them 32-bit or 31-bit?
not a year full time, but the contract started last March 14th. And, I'm not really working on it anymore, but the contract's not over for a couple of weeks. The customers,
To make it 32-bit,
we raised the limit to 33,000.
Very good.
Okay. I'm glad you didn't take me seriously. Yeah.
Yeah, this was not every numeric value computed by...
No, not arrays, things you typed into functions or into immediate execution statements. So it meant that the code string that represented a line in a function or an immediate execution only had symbols and pointers to the name table. So if you typed in 2.3, that was a pointer to the name table. If you said that constant someplace else, pointed to the same place in the name table. And then it meant we had to add code that would get rid of unused constants.
Yeah, he's not using 2.3 anymore.
Well, if the choice is symbol table full or scanning the name table, we scan every code string and mark those in use, and anything not in use, we'll delete it. We do that every time you typed in right paren symbols so that we would give a correct answer. And also, rather than getting symbol table full. Most companies didn't really care about that thing, but we had one that did, and they paid to do this upgrade. Yeah? You look like you had another comment. I'm just about done. Let me finish up and then we can talk. But, attached to the name table is a value. It's pointing at the same value you'd get if you had typed in that value, and we didn't put it in the name table.
And the
Now, the question is, why did we do that? And I'm not sure. I know.
I don't either, but I'm curious. The fix you've been working a year on, was it to remove that feature or to extend the number?
No, it's to allow,
Symbol table.
like I
Name
said,
table.
to allow more.
Was it to allow a bigger name?
Allow more names in the name table. We basically made it unlimited.
2 to the 15th was not enough.
Yeah, I got that.
Oh, it was more than, no, it was 2 to the 15th. Because
I imagine two fixes.
in our representation, we stored the negative index to the name table. So we could have 2 to the 15th different names. Now we have the negative displacement into the name table, so we don't have to shift things by 3 bits anymore. It's just very slightly faster. I rather doubt it makes any difference at all, but the customer is delighted. So I'm delighted.
Oh, it's still, are you saying it's still 16-bit?
No, we went to 32-bit.
Oh, okay.
tokens for code strings. So code strings became larger by, it depends how, we were worried that, in theory, they could get twice as big. But that's only if you didn't document your code. So the more you documented your code, the less of a problem this was. And that should be true, by God.
This reminds me, what you're telling us reminds me of the joke Al Perlis had about, he said that this is an OS 360 joke, but it can be an APL2 joke too. Two guys digging a hole, one at the bottom of the, and hauling up dirt, the other one dumping the bucket out, bringing down, and I've been working for a while, and the guy at the top says, hey, what are we going to do with this dirt we got up here? We got to get rid of it somehow. Ooh, that's the hard one. I didn't think of that. Let me think. Well, they work a while, and the guy at the bottom stops and says, I know. We'll dig another hole and put it in. Okay. So then the guy on top said, hey, but what do we do with that dirt? And the guy at the bottom said, you idiot, the second hole we dig twice as big.
His name was Ponzi.
I don't know why that reminds me of another completely unrelated story. A guy's up there nailing shingles on the side of a house, and he picks up a nail and nails it in, and picks up another nail, throws it down, and throws down, and picks another one, and puts it in. And the guy running the team said, why are you throwing some of those nails away? He said, well, the point's on the wrong side. He said, you dummy, those are for the other side of the house. Apropos of nothing. Well, this is really the end. In the end, I like to think that I didn't compromise on the principles, that there are things that I'm still not happy with. I think APL2 is an elegant notation. I'm very proud of it. The other extended notations are all elegant in their own way, and vive la différence. So that's the end of the formal presentation.
Thank you, Jim.
Very good.
Got any more stories?
I probably do.
Yes. Yes. I should have been more careful when I brought up that topic.
Actually, I have a question for Curtis. How zealously do the cops check the parking meters outside here?
Very.
Oh dear. I better run now. And is there meter-free parking off on 6th Street, anything like that?
There may be some parking on San Fernando Street down towards the library. You get out, a couple blocks
That
into the neighborhoods around the campus, and there's neighborhood parking that doesn't apply on Saturdays.
I'll walk with you. I mean, how long are you going to be here? For half an hour longer?
I've got
Half hour max.
I've got a few more quarters left, but there's a sign at the meter that says,
Hold on the next spot.
Oh, yeah.
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 What does
These
it say?
meters are getting too
Tell me
smart
what it
now.
says.
What it says is you can't get around this 1 hour limit by adding more money. We will.
Well, they're here in Santa Monica now. I mean,
So-
the parking meter notes your license number, and you can't even park someplace else on the same block anymore.
Oh, God.
It's amazing.
Okay, so,
Technology.
I'll walk with you.
great.